Section 1.3. You got a problem? So objective 1, let's identify the 4 steps in our problem-solving procedure. So this is basically steps on how do we approach word problems. First step is to understand the problem. The best way to start any problem is to write down information that is provided as you come to it, especially with longer word problems. If you read the whole thing all at once and you do not do anything, it is easy to get overwhelmed. If you read the problem slowly and carefully, writing down information that is provided, you will always at least have a start on the problem. Another great idea, carefully identify and write down what they are asking you to find. This almost always helps you devise a strategy. Step 2. Devise a plan to solve the problem. This is where problem solving is at least as much art as science. There are many ways to solve problems. Some common strategies, making a list of possible outcomes, drawing a diagram, trial and error, finding a similar problem that you already know how to solve, and using arithmetic, algebra, or geometry. Step 3. Carry out your plan to solve the problem. After you have made a plan, try it out. If it does not work, try something different. There are many different ways to attack a problem. Be persistent. Don't give up. Step 4. Check your answer. It's always a good idea to think about whether or not your answer is reasonable. And in many cases, you will be able to use math to check your answer and see if it is exactly correct. So basically, make sure your answer makes sense. Make sure it's not outlandish with the numbers and the information given. Let's actually apply this problem solving. A private college is given a grant from a wealthy alum to build a sculpture garden where statues of the first 8 presidents of the college will be installed in a straight line from earliest to most recent. Each statue will be 8 feet tall, 2 feet wide, and the sculpture decides on a consistent distance of 12 feet between the statues to reflect the 12 decades since the school was founded. How much space will be needed from the beginning to the first statue to the end of the last one? So the first thing we need to do is understand the problem. At this stage, it's always a good idea to clearly identify exactly what we're being asked to find. In this case, it's the total amount of space needed. That's exactly what we're trying to find. It says how much space will be needed, so that's exactly what we're trying to find. We should also identify the useful information we've been given. There are 8 statues, each of them are 2 feet wide, and they're going to be installed in a straight line 12 feet apart. Notice that there's also an extraneous piece of information. We are told that the statues are 8 feet tall, but that has no bearing. It has nothing to do with space in between things. The world doesn't always give you exactly what you need and nothing more when solving a problem. It is a very valuable skill to be able to pick up on what is and isn't useful. Step 2, let's devise a plan. Here's a good guideline to keep in mind. If you can draw a diagram, you probably should. That sounds like an excellent approach here. A diagram with the statues and all the relevant measurements will most likely allow us to calculate the total space between the first and last statues. So if you can draw it, do it. And that is something that we actually teach all the way through calculus and high-level math. If you can draw the picture, you should, because sometimes a lot of the times, it's much easier to see what you're talking about given a picture or drawing a picture for yourself. So let's carry out a plan. Let's draw the diagram with 2 feet width of the statues that are 12 feet apart. So this is where we're going to actually start to carry out what we're talking about here. So we have a certain amount of statues and a certain amount of distance they need to be apart. And it told us already that we are going to have 8 statues. Let me change that color. We're going to have 8 statues. So let's draw each statue that's 12 feet apart. So we have one statue, and it told us that each statue is actually 2 feet wide. And then it says that we want them to be 12 feet apart. So that's one statue. Now we have another one. It's 2 feet wide, and again, it needs to be 12 feet apart. So that's our second one. We have 8 to draw, so we have 6 more. Here's our next one. So 2 feet. I know my drawing skills are amazing, thank you. I can draw a diagram, doesn't mean it's going to look pretty. So there's our fourth one. Here's our fifth one. And they're 12 feet apart and 2 feet wide. Here's our sixth one. Here's our seventh. And again, 12 feet apart. And here's our eighth. So since there is no more to account for, we don't need that to be 12 feet apart. It's just in between we want them to be all apart. So since we have this diagram, this is essentially what it'll look like. We're just going to have fancy statues of the presidents of the college. So what do you think we should do with all these numbers? When I ask questions like that, they are not rhetorical. I really do want you to answer them while you're watching this video. We've all watched Dora the Explorer or Blue's Clues and like stuff like that. We do that for a reason. If I'm saying or asking a question, answer it either in your head or out loud. You're never too old for that. So, what do you think we're going to do? We're going to add all these numbers. We're going to add them all up and see how much distance we have. So we have 2 plus 12 plus 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 2. So if you count, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 twos. That means we have 8 statues. And if we add all of those up, we actually get 100 feet. So you need 100 feet to create this statues. Or there's another way to think about this. Another way to think about this is, do you notice that we have 8 twos and 7 12s? Because we have 8 statues. So if we have 8 statues, we're going to have 7 spacers between them. So we actually have 8 statues with 7 spaces. So we know that if we have 8 statues, they're 2 feet wide. And then we can add that to the 7 spaces that need to be 12 feet wide. If you add all that up and multiply, 8 times 2 is 16, 7 times 12 is 84, and we get 100. So there's another way to think about that. One is using a picture, a diagram, and another one is essentially using algebra. Check your answer. That's our last step. Sometimes an answer just kind of checks itself. It just makes sense. Since we have the diagram, we can see that it matches all the conditions laid out in the problem. 8 statues that are 2 feet wide and 12 feet between consecutive statues. It's exactly what we needed. Alright, let's practice that again. Solve problems using different strategies, trial and error, drawing a diagram, algebra, using other ways to think about it. So you graduated from college and you're ready for your first job. In fact, you have 2 offers. One pays an hourly wage of $20.75 per hour with 40-hour work week. You must work for 50 weeks and get 2 weeks paid vacation. The second offer is a salaried position offering $41,000 per year with an opportunity for a $5,000 performance bonus. Which job will pay more? Which sounds like a better opportunity financially? So the first thing we need to do is pull out information from each job offer. So we have 2 job offers. Offer 1 and offer 2. So offer 1 says 20.75 per hour, and you have to work 40 hours a week, and you have to work for 50 weeks and you get 2 weeks off. Alright, so that was the first bit of information. Our second job offer, you have a salary of 41,000 a year. And then it says you have a potential to earn a $5,000 bonus. So now we have the information brought out. We need to determine things. We need to figure out, okay, what is going to give me more money? And then we're going to ask ourselves which job is likely the better opportunity. And those are actually listed as the questions they want us to answer. So step two, we need to devise a plan. So our plan, we have to figure out how we're going to break this down. Well, we should probably calculate the earnings of our hourly job because then we can compare that to our salary job. So to compare the two job offers, let's calculate the annual earnings from each offer based on the information, and then we're going to consider any potential bonuses or benefits that can affect the total. So our third step is to actually do the plan. So execute our plan. So our first job offer, we have an hourly wage of 20.75 per hour. You're going to work 40 hours a week and you actually work for the amount of 50 weeks. Okay, so we're going to multiply. Why do we multiply? Because if I work for 40 hours a week and I'm making 20.75 an hour for 50 weeks, we multiply to get our total answer because we want to know it's how many times we're doing this. It's like if I have 3x, I'm xing 3 times. So we're seeing how much money are we getting for 40 hours a week for 50 weeks out of the year. So we are paid 20.75 per week per hour. We work 40 hours a week for 50 weeks. So 20.75 times 40 times 50, we have 41,500. That's our first job offer. Our second job offer, it's salary. So we really don't have to do much math because it's saying you're just going to work and this is how much money you're going to make. But it says we have a bonus of $5,000 potentially. So it told us our annual salary was 41,000. However, we could get a bonus of 40 or $5,000. Sorry, I was already doing my math in my head. So if we add that up, so we have the potential to earn 41,000 plus 5,000, which is 46,000. So based off of this, the second offer is better. You will ultimately most likely make more money. Let's check our answer. That's step 4. So job offer 1 is 41,500 annually. Job offer 2 is 41,000 with $5,000 bonus, so that's 46,000 annually. Job offer 2 pays more annually compared to job offer 1. Job offer 2 also sounds like a better opportunity financially due to the potential for a performance bonus which could increase earnings beyond the base salary. Therefore, based on the comparison of annual earnings and the potential for additional bonuses, job offer 2 appears to be the better financial opportunity between the two. Strategies for understanding problems. One reason that problem solving is a challenge is that every problem can be a little different, so you just can't memorize a procedure and mimic over and over again. The steps are similar, the concepts are similar. However, the way we approach the problem and find an answer is going to be different every single time. If the problem describes something that can be diagrammed, a drawing almost always helps. Draw it if you can. If you find that you read through a problem and feel like you have no idea where to start, you should consider not reading the entire problem at first. This can sometimes lead to feeling overwhelmed or intimidated. So I do that. When I read a word problem, and especially if it's a massive word problem, I will read it and be like, what did I just read? So take it sentence by sentence. Write down all the numeric information on the problem as you read it. This often helps to organize your thoughts. But maybe more importantly, it is a guaranteed way to get a start on every problem, so you avoid the moment of panic when you feel like you have no clue what to do. So just bringing out numbers and bringing out saying, this means this, we're saying you're making this much money. When you bring out the information, you're not stuck. You're already doing stuff. Sometimes making a chart to organize information is helpful, especially when you are trying to use trial and error. Don't expect that you will know exactly how to solve a problem after reading it once. Most often, you will need to read through the problem several times, and even then, you may need to just try some approach before finding one that works. So just try. Trying is the majority of the battle in all classes, especially math. Just try with stuff that you can pull out, numbers you can pull out.